at least get it recorded. So this is not super prepared because so what we're gonna do today is play with this, which is the USB test suite by Antmicro, which is this like a simulation thing written in Python using CocoTB, which is like the co-simulation thing, which is designed to test the compliance of several FPGA IP cores for USB. So you see they test Foboot, they test Valenti USB, they test a USB 1 device from, I don't remember who did that. Well, they Antmicro, so it's to simulate their own core. And they also simulate my USB core, which is in an ICE40 playground, to test its compliance to different scenarios. And something, and so I've tested this like test suite a while ago, like several months ago. I think it was right after I met the guys at SuperCon last year, and Mitro pointed me to this. I had a quick look and ran them and stuff like that, but I didn't really play a lot with it. But today what I'd like to do is add some testing, some more tests for all the retry procedure. So if we look at the USB specification okay, where is it? I just need to find the diagrams I'm looking for. Okay, yeah, these kinds of diagram. Well, this one is for isochronous. Isochronous. Yeah, that kind of stuff. So these diagram, they basically like an action or state diagram that dictate how the USB device must respond to query from the host, and it includes like a retry mechanism, so that if some packets become corrupted on the wire, like the packets were not exchanged properly, that will be detected and that will be retried. Currently, as far as I can tell, the USB test suite here, they just, they test the enumeration, but they test it in the scenario where everything goes right. And what I'd like to test is make the host fail a packet, like not, for instance, like don't acknowledge a packet and then retry the reception, for instance, and see if the USB core responds correctly and does indeed resend the packet properly and things like that. So basically, currently we test, okay, that's the case where everything goes perfect, and I want to test the error response if it's actually compliant with what the spec says it should be. Because, I mean, I tested them like, very simply in some test bench that I wrote, but it wasn't super easy to test in test bench, and I think that this framework would be perfect for, well, testing that and testing the compliance. And the advantage is not only does it allow me to test my core, but at the same time, the same test suite can be used for all the FPGA IP cores for USB that exist, and run the same test and see, do they pass the test, and if not, how can they be fixed so that they actually do pass it. So let's first try to actually run this and set it up. So I'm just gonna copy the URL. So as I said, this is not really prepared because I only played with that a long time ago. So this is just gonna be me going through the whole setup. Hey, hi, DVD Freitag. So, so I did have an old checkout. So yeah, so the last time I tested this, that was like a like 4 months ago, or almost 5 months ago. It has been updated since, so I think I'm just gonna start from scratch. I will keep the directory just in case I have something in it, but other than that, I'm just gonna reclone it, of course. Nuke the buffer. So they say to execute the script setup.sh, but I just basically run the command manually because some of the steps I will run slightly differently, but not that one. Just check out all the submodules. Yeah, that's the one thing I'm not like super fan about in Lytx is like this is gonna check out like every single Lytx device and sub device. Like, why do I care if I clone PCI Express or Ethernet or SD card or video? I end up with like 1.1 gigabyte of stuff I don't want. It's just annoying. It's practical, but it's a little wasteful sometimes. What are the other steps? You can do that already. Yeah, Vivado is definitely most likely the biggest. Like if I data. So yeah, I have like 56 gigabyte dedicated to Xilinx at the moment, and that's just. Or I have two versions of Vivado, but I also have ESE, USB. Yeah, I need multiple versions of Vivado because some of the projects I built, they're meant to be built with the previous version, and sure, most likely they would build fine with the new one, but it's always a risk. Like, you know, the bitstream has been tested on this particular version, and so I'm just running it on that one. So yeah, that's on a USB stick, and I also need ISE, which is like the one for Spartan 6. Although, I mean, to be honest, Drew, I'm not sure how soon you'll be able to get rid of Vivado, because I think there is still quite a bit of work to do before that happens. Like even for the ICE 40, which is arguably like the most mature suite of open tools, I still need sometimes to refer to IceCube, which is annoying, but it still happens, right? Yes, I think some modules can do shallow clones, but I'm not sure how to specify, because of those recursive subjects, I need some of them, right? And so I'm not sure how it's possible to specify, okay, yeah, I want this one, but not this one. Because that's like several layer deep in sub-modules. What is it taking so long? Oh yeah, and there you go, 21 more giga. So I have like 80 gigabyte dedicated to Xilinx tools. Thankfully, I don't have to work with Altera FPGA, so at least I don't have to have that. Oh wait, it's waiting for what? Oh, it's waiting for a password to check. Oh great, one of the sub checkout is password protected. Outstanding. Yeah, I know it supports depth 1, but the problem is I can't just stop at depth 1 because some of the submodules that are at depth 2 are needed, just not all of them, right? And so how do I specify that, you know, at depth 2 I want some, but not all of them? That's the problem. I can't just stop at depth 1 because it's not gonna work, right? Because in the submodules, you know, there is like I don't need the video or the SD card, for instance, but I need USB, right? Oh, you mean okay? Okay. So it's not that it doesn't recurse more than one. It's just that it doesn't fetch the entire history of the thing. Okay. Yeah, I could have done that, I guess. But yeah, Mike, I actually saw this morning that I thought they just updated the test bench like today. Maybe they didn't. They bumped some. Like they just oh no, they bumped Light X. But they have not bumped Foboot. So they only bumped some of them. I got a notification this morning because I followed the repository that a bunch of the submodules were updated. And they bumped Yosis, they bumped Litex, but indeed, like Foboot hasn't been bumped to the new one. Okay. Anyway, so the failed to recurse in Foboot. Okay, yeah, I'm not too worried about that because mostly I want to. If I can't check Foboot, that's fine. So let's look at the README. So setup, okay, usage. So yeah, activate the environment, then make sim, and readme in test bench for details, okay. Okay, so let's try that. First, let's check we were done with the setup. No. Still need to do this. Yeah, and here the Lytix setup is recloning every single thing that's already in Foboot. Okay, we'll just wait for that. Yeah, but if the only issue is the fact that it doesn't, is that I can't push, it's not so much an issue because worst case scenario I can just I would only do like a shadow clone of the Lytix stuff and not of the main test bench repository. Okay, so we should be ready to go to the test bench. So here I should be able to do something like that. Ah, shit, I've used it wrong. Okay. I need RISC-V toolchain in my path. Why is it looking for RISC-V unknown if in my make file I have RISC known embed? Yeah, Drew, I just pressed enter. Each time it asked for a username and a password, I just pressed enter. And it didn't clone some of the directory, but I don't care. Like I don't need the Minerva CPU core or anything like that. So as far as I could tell, all the one is skipped. I didn't care about it. Ah, yeah. It specified cross equals something. So I'm just gonna override it here. So the thing is, it's applying some patches before running the simulation, and yeah, How do I prevent it from doing that? So what it's doing is, it has some patches which it's trying to apply to the checkout, and it already applied them. So I want to stop it from applying them twice. I mean, I guess I could. Yeah. Okay. Let's do this. Oh, shit. What? What is it trying to do again? So the thing is, it's trying to, like, it calls it with RISC-64, and that's just not the prefix I use for my compiler, and so I just want to prevent it from messing around with the cross setting. Let me just grep for that. Let's try to find where. That's the problem with that kind of fully automated test bench, is that if you don't have like perfectly the same setup as they do. Okay, do this. Okay, so the patch has been applied, so I'm just gonna. Okay, yeah. I think I must have pressed like a mute shortcut or something. It's just the volume slider went to the to the 0 setting. Sorry about that. So it's running the simulation. And what is it? So it reset the port. I haven't run this simulation before, so I have no idea what it's supposed to do, but I think it's waiting for 1 millisecond. It's definitely doing something. I'm not sure what to expect, to be honest. We can try to. Oh well, it's okay. It did something. Okay, so it tried a get device descriptor, setup stage. Okay, so it executed the device descriptor, got a NAC, which is a valid response. That means the firmware isn't ready. And again, he just retried a bit later, and it got the data, I guess. I mean, it's saving everything in a VCD file, so we'll just look at everything once it's done, basically. Okay, so there you go. It passed. Good. 0 errors. So now let's try to look at the VCD that it generated. So yeah, it generated a dump.vcd. Let's just load it in GTK wave. Oh wow, 659 megabytes. Perfect. And so yeah, it saved every signal of the PyQRV and the USB and everything, but what we're interested in is the actual USB line and the clocks, I guess. And so here we can see all the packets that have been exchanged. Obviously, that's a little hard to read by hand, right? So let's try to actually decode the USB packets using a script to do that. I have not it set up on this machine, but I guess that's a good opportunity to set it up, right? So, where well, how am I gonna find it? Like USB decode, GTK wave, SIGROC. Yeah, there you go. So that's a script I wrote, which basically takes the output of GTK wave and allows to pipe it into a SIGROC filter to decode it. And it even tells you exactly how to do it for USB as the example here. So let me download that. Of course, for that to work, you actually need SIGROC, which apparently I do have. Okay, cool. So let's try to add that. So the problem is it doesn't always detect which one is P and the P and N signal. So let's see if that works this time. So we need to group the traces. Combine. B. And then we want to add a transaction filter process. Oh, damn it. So it's selected. Okay. So now it should be running the entire capture through the SIGROC. Yeah, we can see SIGROC is using a lot of CPU. I mean, it's definitely not the best UI integration of that script, right? But it's kind of convenient when it works. .600 megabyte capture, I guess we have some time. So what the script is doing, it's really just. What about Wireshark to decode? Well, the Wireshark doesn't do that because what you need to Wireshark would only be able to like show you an interface to dissect the packets, but you have to provide it the actual bytes, right? And here we don't have the bytes. What we have is the positive and negative data lines, and we actually need to find where the packets start, decode, recover the clock, extract the bits, form the bytes, and then once we get the bytes, we could actually feed that to Wireshark. But yeah, you can't feed a VCD to Wireshark here. Wireshark is like one level above, if you will. Yeah, that's taking its time. And I'm not even sure if it picked up the right, because sometimes it swaps USB P and USB N, and so it doesn't decode correctly at all. I've not found how to fix that, although I haven't looked very hard either. But wow, that's taking a long time. 2 minutes. I mean, the capture is like 600 megabytes, right? It's several milliseconds of hardware simulation, which for a CPU running at 48 megahertz is like yeah, quite a few cycles. Well, I mean like 50,000 or so. Damn, this is taking way longer than I remember. Maybe we can look at the test bench and possibly find a shorter one. So what we run is test W10nm, which is, I'm guessing, is simulating like what Windows 10 does during the enumeration. We can possibly find a shorter one. Like what does test basic do? So that we don't have to go through that every time we want to try something. Test control transfer in. Ideally, I'd want like maybe just a get descriptor. I mean the reset and then a get descriptor. Like that actually looks. Yeah, this one looks a little shorter. So maybe we can use that next. It does the reset. sets the address. I mean, it does the get device descriptor. Well, actually, we can just write our own, right? That's kind of the point. So we can just edit test enum and basically stop here. Like just getting the device descriptor would be enough, and we can, during the get device descriptor, like manually introduce an error and see if it recovers properly. Okay, so that didn't work at all. Yeah, I mean, it didn't detect the packets at all. It didn't even detect the bits. So detected the reset phase correctly, but yeah, it swapped USB P and USB N, and I see it starts here instead of starting decoding here because it swapped USB P and USB N. I have no idea how to tell it to not do that. It's just fucking annoying. Okay. Does this have the ability to cut a file? No, I don't think so. So let's run a smaller test bench. So it says to run make clean every time between run. So I'm gonna do that. And in the test, we're gonna modify test enum to only do the get device descriptor basically. We're gonna shorten the test and only comment everything here. Let's try to run that. In the meantime, we can look at that script. So in that command line here, there should be a way to tell him the name of the signals. So I need to find the syntax for SIGROC protocol decoder. There's no SIGROC expert in the chat by any chance. That's how to write a protocol decoder. I don't want to write one, I want to call one with known signals. No. Okay, so that my So that'd be dash A. You want Rx. Is there a way to query a protocol decoder? So if I do sigrocly, does that help? Dash dash show. Okay, so the channels are DP and DM, and I need to because basically in the VCD file that's used as input, the so did it finish running the simulation? Yeah, it finished running the simulation, so I should have a new VCD file, which is, oh yeah, it's slightly smaller. No, it's only 450 megabytes. So yeah, they're named USB DN and USB DP, and the sigrocly expects DP and DM, and so it doesn't really recognize them, and so I need a way to kind of bind which is used for what. And I don't know how to do that. That's not A. Okay, so here TX. Okay, so you can just say the DP and the DM, and then the name of the channel, and I'm assuming the name of the channel is gonna be the name in the DP and DM. USB, DP, DM, USB, DN. See if that works. Combine the signal into one USB, and then data format, transaction filter process. This is doing something. The question is, so we gotta wait for that to run and see if that did any better. Excuse me for a second, I'm just gonna go grab something to drink. That. I mean, this SIG rock integration is in GTK Wave is really kind of a hack, right? It'd be much better if it was better integrated with like a UI or something, but at least it was quick to write, and it's like super convenient. um, I've debugged like SPI, USB, I2C with that. It's a bit of work to get it to work, and on such huge captures, it's not. You have to wait a while before you see the result, which is definitely not great. But usually, when you work with smaller test benches, you only have captures that are not 500 megabyte, and then it's pretty much instant to see the result. Oh, I'm sorry. I don't follow. I don't look at the activity feed all the time. But Aaron Steele and Nico Celedon, thank you for the follow. But yeah, so what I wanted to explain is how this script actually works, and it's like in GTK Wave you can select transaction filter process, and what this does is it basically selects a few of the signals that you have in your complete trace, and it starts an external sub process, and at the standard input it just feeds it a VCD file with just those signals that you selected, and at this standard output it takes like specially formatted annotations that allow you to like do annotation here on the graph here. So let's see if that works any better. I detected the result at least. Okay, let me zoom a little. Okay, so that looks much better. But so at the moment you only see the 0, 1, 0, 1, 0, which is not like super useful, right? But that's because there are several levels, several traces, and so you need to add a blank line and position it just before, just after, and then you see the actual symbols, kg, kg, if you're familiar with USB signaling. Then you can add another blank line, and then you get the packets. And then I think that's it. I think there was nothing more later. But then, okay. Now we have actually the USB packet decoding, and we can actually start looking at what our core did. So you see, here we have a start of frame, which has been sent by the host, which has the sync field, the start of frame field, the frame number, and the CRC. And here we see that we have a setup packet, setup packet, which is like just a token packet for setup, to address 0 and point 0, again with the CRC. And then here we see it's a data 0 packet with those bytes. And see, Drew, here we only get the bytes. We actually don't even get like packet decoding of the various fields of that. This is a get descriptor request or anything. So you could actually somehow feed the result of that to Wireshark, but currently I don't think there is anything that allows you to do that. I don't think the SIGROC CLI protocol decoder has any output that can be fed in Wireshark for analysis, but that definitely be convenient if that existed. Okay, and so that's kind of where I want to introduce an error, okay? Because here we have the start of frame, and then we have this packet, which is the get descriptor request. And here we have the response. well, no, we don't have, here we don't actually have the response yet. So here, so okay, for those of you that don't really, that don't know USB, this asks the device to describe itself, send what's called the device descriptor. So that's basically, you know, when you type lsusb -v, you get all the details, right? And the device descriptor, that's kind of this part. I mean, technically it's the entire part, but at first it will only ask for this. Will describe, you know, what kind of ID it is and stuff like that for device identification, and that's this request. So it tells the device, the host tells the device, okay, send me your device, your device descriptor. And then here, okay, it asks the device, okay, are you ready to send it to me? No. Okay, it waits a little. Are you ready to send it to me? And here in this case it is ready, and so it sends the actual data for the device descriptor. And that's the packet where I would like to, well, I can't introduce an error here because that's sent by the device, but here the host sends a hack, and instead of a hack I want to send a knack, so that the host tells the device, okay, what you sent me previously, I didn't receive it correctly, like the CRC wasn't good or whatever, and then it asks again, and in theory it should send the exact same thing again, and that's kind of the test that I want to do here, to modify the USB test tree to test that. Because if we look in the USB specification, so that's out transaction. Now we want an in transaction. So that's the state that the device follows for this this kind of transaction. It's no, sorry, that's not it. That's okay. Device do BC. Okay, finally, yeah. And basically, if there are data available, it sends the packet. So that's the first step. We have data to send, and we send the packet. That's what happens here. So basically we get an in token which gets us into that graph, and then we check, do we have data to send? Yes, we send this packet. And then here we wait for a response from the host. We get a response from the host, and currently the response that we get is acknowledge, and so we do next data, which is basically move on to the next packet, right? We're done, it's been sent successfully, but instead what we want is to send a knack. So if we don't get a response at all, or if we don't get a response at all, or if we get a response that's not an acknowledge, then we stay in the same state, which basically means that we're staying on the same data. Basically, we don't execute the do next data process, which moves us to the next packet to be sent, which means that when we get the next in request from the host, we're gonna send the same data again. And that's what I want to test. So let's see if we can do that. So was I clear at all, or is that gibberish? I hope you did you did follow. Yeah, they're not actually that bad. Like when you dig into them, there are a bunch of chapters that you can, like mechanical. I, couldn't care less about the mechanical properties of the USB connector, right? Electrical, most of them, at least for the protocol level, like you don't care about the impedance of the cable and stuff like that. So most of the time you can skip that as well. So the most interesting is definitely chapter 8. Chapter 11 which is like half the specification. Is like here we're at chapter 11 and we're at page 325 out of 650. And so if we look at Annex A, so chapter 11 by itself is like 150 pages, and that's like how the hubs must work, and that's for coding or interpreting like a device spec. It doesn't matter either. So chapter 8 is definitely the most interesting. All of that is just pretty much introduction, like 1 through 5. Yeah. So and those diagrams. Which no, I don't know where I found. Actually, pretty easy to follow. Like they're written mostly in English that you can understand, right? You just have to know that okay, HC is host controller, which means if you implement a device, you don't really care about those, and you can only look at the device, the dev one, and then it's fairly easy to understand. Okay, what am I supposed to do? Especially when you read the corresponding text. Okay, so here we see that in our test bench we just basically call helper method, which is get device descriptor, which means we need to dig into the get device descriptor to know how this is gonna work. So at the moment I'm just gonna like not worry about the proper way of writing a test for it, because like every time I do a get device descriptor, I obviously don't want to generate an error. Like I only want it to do it sometimes, so I'm gonna have to at some point add a parameter like generate error or stuff like that. But I don't know yet the proper architecture or how to do that because I don't know this code. So at the moment, I'm just gonna dig and add what I need at the places where I need it, and then I'll worry about I can clean it up for submission upstream, and or we can package that into a proper test basically. So it uses the test harness, and I think the test harness is actually not in this repository at all, because these are just the test sequence, but it doesn't contain, like the test harness itself is in another directory, CocoaTB USB, I think. Yeah, this. And I'm pretty sure that here we have a get device. No, we don't. Okay. Well, let me just go there with Vim so that so test suite CocoaTB USB. So I'm just gonna make it clean and switch to CocoaTB USB. Get device descriptor. Okay, so it generates a control transfer in, which makes sense. And control transfer in. It will execute transaction data in. So if we look at the different steps, that's what's called the setup phase or setup stage. like the initial packet that sends the okay, it is completely unreadable because it's white on white, but it says setup. I mean, we can probably read it here. Yeah, it says setup address 0 apply 0, and then the actual request here. That's what's called the setup stage, and so this is done by this. And then we have what's called the data stage, where data is actually exchanged between the device and the host for a configuration request, and that's essentially this entire part up until the acknowledge here. I mean, the first transfer is unattempted, but the device responds that he is not ready, and then the host tries again, and then here it's ready. So we have to look at the code for transaction data in. So here we have transaction data in. And so what does it do? So it's called host receive. Okay, let's look at host receive. Okay, so that's, we can see that here it sends the in token, which is this part. That's the input token. Yeah, see here, in, that's the host telling the device that it wants to receive data, and then it receives a packet from the host. Host expect data packets. Host expect data packet. I'm just looking for where is the retry of when it gets a knack. How does it how does the flow work? Because I'm not super familiar with CocoaDB and the whole yield thing and how the coroutine of CocoaDB work and stuff like that. So I understand that, okay, this sends the token packet, yeah, makes sense, and here it's waiting for the packet, but how does it leave, how does it quit the loop if it gets the actual packet or not? Okay, so this probably hits. So it gets a knack and retries it. So what we could do is, instead of sending okay, I still don't understand how it, because what I want is here, instead of sending a ACK, is the first time around I want to send NAC instead. But that means that I need to understand like the control flow and how does this quit the loop or not. Oh, well, okay, this sets retry to false, right? That's, and then I'm guessing that this tests retry. Yeah, okay, so I understand how that works. Okay, so I'm just gonna act something quickly here. Wait, first I need, so if we have received the data, but we need to do a NAC, instead, we're not gonna add NAC. Okay, there is no function send NAC. Where's the function send NAC? Okay, so that should be it. When we do a receive, instead of, we're just gonna basically, every time there is a in transfer, we're just gonna force an error by knacking the transfer and forcing the device to send the same data again. Let's try to simulate that. So while that's simulating, I can actually show you how it is supposed to be handled in the USB core itself. So if we look at the USB core code, data. So the transaction these state machines and the decision and everything that are specified here are actually implemented in my USB core using using a microcoded state machine. And so if you look in the USB utils, you have microcode.py, which is basically like a minimalistic compiler, or no, not compiler, just an assembler for the few instructions that are supported by the microcoded state machine. And then you actually have the code for the state machine that implements the various possibilities and how they reacted and stuff like that. And so if we look at the code, we see that it waits for an event. If there is an event, it looks and dispatches it. And so if it receives an in packet, it jumps to the in transaction code. And then we see, it checks which is the endpoint type, and if it's a BCI transfer for bulk control interrupt, which is exactly what we have here, def do BC int. It checks different conditions, stuff like that. And if there are data, it essentially sends the command to the hardware to transmit the buffer which is pending. And then it waits for the transmission to complete. And then it waits for an acknowledge, or it waits rather for an event, and then looks, okay, is if what we got is if what we got is different, if what we got is an ACK, we have success, and then we mark the data as being sent and we proceed to the next. And more importantly is we set the buffer state, so the buffer descriptor that describes the packet we just sent, we set it to done. And if instead it's not an ACK packet that we received, or if we have a timeout, which is exactly what's described. Sorry, that was the wrong graph. We're doing a BCI in. It's the graph we were looking at last time. Do we see? No. Yeah. If we are receiving not an acknowledge, or if we have a timeout, which is exactly the condition here, if the flag Eric's OK is 0, which means that we have a timeout or a bad packet has been received, we jump to fail. Or if it's not equal to acknowledge, which is basically it's not an acknowledge, we jump to fail, and then we do nothing, which means that we will on the next request we will retransmit the same packet in theory. And that's with this microcode, essentially, that the entire USB states and retry process and stuff like that is implemented in that USB core. Okay, let's check. So it did still pass the test, which is nice. Now the question is, did it actually do what we want, or did it just not do anything? Let's check this, so we can just refresh the thing, which will rerun the what I'm wondering is actually if it will execute the no, that microcode gets compiled essentially as a binary code which is stored in a block RAM, and then I have like a dedicated microcode execution engine which executes that. That's the way I chose to do it, not in gate level. So if you look at the RTL source code, that's it. That's essentially a minimalistic CPU, if you will, that can only execute very few instructions, which is what that microcode is written with. Yeah, microcode execution engine. The way the code this core is coded, you have the packet level handling, which is really the bits and the different fields inside the packet is handled entirely by gateware at the gate level, because you need very short response time, and you don't have any time to lose with executing any kind of software. Then you have the transaction layer, which is those state machines, stuff like that, and these you don't need to respond in one cycle. You have 6.5 bit time, which, because I'm running at 4 times the frequency, is actually 6.5 multiplied by 4. So I've got like 24 or 25 cycles to actually respond to whatever condition occurs. And so it's not enough for a soft core like a RISC-V or something to execute full software and execute those states fast enough, but it's fast enough for a microcoded state machine to make those kind of decisions. And that allows me to reduce the size of the gateware and also be much more flexible, because if there is a bug in the microcode, it's much easier for me to go and fix it than if I had to change gate level logic, basically. And the other advantage is if I need for my USB core to do something that's not standard, like do some weird things, I can actually just update the microcode, and I can even do that dynamically, because I could make the RAM that contains the microcode, make it writable by a soft core, and so the soft core would be able to patch its own microcode dynamically to generate some weird things. Yeah, I wrote the USB, that USB core is written from scratch. Like I entirely wrote it. Before I wrote it, I didn't know USB at all. Like I had never read the spec or anything. Basically, I wanted a USB core that ran on the UP5K because I saw the tiny FPGA BX bootloader, but it had some issue. First, it wasn't a generic USB core. It was designed to do one thing, and that thing only. And it also had a very hard time meeting timing on the UP5K, because it was designed for the LP variant of the ICE40, which has a faster fabric. And so I basically decided to just learn USB and write my own USB core at the same time. And because it was for FPGA, some of the design goal that I had was that it would be fairly small. And so this one fits in about 500 LCs, so logic cells of the ICE40. And also I wanted it to support every transfer mode and endpoint configuration and so stuff like that. So you can have like 32 USB endpoint on that core, and it doesn't change the size of the core. The size is fixed and supports all the options directly. Which allows me to create, like if I wanted to create USB device with 31 like UART, I could do it, and the core would still be 500 LC. It doesn't take more logic cells per the number of endpoints that I had. And the other thing is I wanted it to support also isochronous transfer. Okay, so that ran correctly. So it decoded, so that's the first device answering. Okay, so that didn't exactly do what I wanted to do because it did send the NAC, but after that it sent the ACK, and which is completely a violation of the specification. But Here that's the test bench which is violating the specification. That's not the device. So the device will just receive an API it didn't expect and just drop it, and then it receives a out. Yeah, I mean, so that's definitely not valid. So I definitely screwed it. But the good thing is at least my modification resulted in some changes, just not the one I expected. So where did I screw up? Where did I edit that file? Oh yeah, of course I need to. I need to force it to retry, right? The idiot. Okay. Clean. And rerun that test. And so yeah, that was for the hardware itself, but there is also the because this core essentially acts like a USB core that you would find on a microcontroller, which means you need a software USB stack that runs the higher level protocol. And currently that's run on the RISC-V soft core. I also wrote the USB stack on the RISC-V that runs this core, but I also have a driver for it for tiny USB. So if you want to use tiny USB with that core, you can do it, and that's, for instance, what's used in the Hackaday Super Conference badge. It's this core which runs, but using the tiny USB software stack, basically. I'm also designing an extension for this core so that you can run it without having a soft core. Basically, like a very simple state machine that would just respond to the descriptor requests and would provide like a FIFO input and output, so that you can easily implement USB to serial or USB to pipe data in and out of your gateway without having a full soft core and software stack running. That would take some space, and hopefully that would be much smaller than a full soft core. I mean, like the soft core, it takes like 1,500 LCs, I think, at the minimum, and I'm hoping to make something that's in like a couple of hundred of LCs. So like in maybe 700 or 750 logic cells, you would have a USB core that enumerates, says all the descriptors, and then provides easy data pipe to your custom logic without having a soft core. We'll try. Derek, soft core less, is that something existing, or is I definitely try. Oh, sorry, somebody is ringing my door. Give me a second. Sorry about that. Oh yeah. So yeah, I will definitely try to get it running on the FOMU. I mean, I know my core with the soft core runs on the FOMU. I've done it, and so I definitely want. That's actually one of the main reason is like the FOMU or the upcoming Bitsy is to have like a very minimal code that you can easily just add to your design with like no dependency or whatever. You just drop in a few Verilog files, and then you get basically FIFO in and FIFO out port where you can easily read data in and out without having to mess with anything, and it just works. And but which would still expose proper descriptors and also the DFU runtime interface, so that the DFU runtime interface is really the minimum amount so that the host can tell the FPGA to reboot in DFU mode, and at that point it just reboots another bit stream, which is the no, it's the Bitsy board is also direct FPGA to USB. I have so here is one of them. Wait, where is the center? Let me check if I can. Will this focus? I have the manual focus control somewhere, but it doesn't want to focus anyway. But yeah, it's direct to this, and so it will have basically a bit stream which is loaded by default, which is like the DFU bootloader. But if there is an application already loaded, it will boot directly to the application. The FOMU you always get to the bootloader first, because since it doesn't have like an easy way to reboot it or a button or stuff like that, it was like the safest way is to always go to the bootloader step. For this board, if there is an application loaded, it will skip the bootloader. But I want the application to have an option to reboot in DFU mode, with always the fallback of if you have the user button pressed once you plug it in, it goes to the bootloader by default. Okay, so it did generate the thing. I can reload this. I should have done that while I was talking. Hey, hi Derek, by the way. Are you streaming tonight, like a third episode? Oh, nice. Okay. Is that so? That's like 8 p.m. for you, right? I know 8 p.m. UTC. So that's 10 for me here. Okay. Oh, I missed an earlier message. Yeah, we spoke yesterday on Discord. I'm looking. Yeah. So, doing it in the FPGA is definitely an option, but then you need a USB host, right? Which is definitely, I haven't looked at that yet, but. But I definitely wrote my USB code to be somewhat compatible with USB host to at least have the option. But I haven't tried it yet or anything. I thought that I saw somewhere a project, FPGA project that did that already, but I didn't dig further. Um, I don't know what kind of simplification you can make if you just want to talk to a keyboard, but just a HIE device with like the boot protocol or something. Um, there was a come on, there is a project that was a US. Oh, come on. It was like a small client. How is that called? Like light, light client kind of stuff, which you just plug a screen and a keyboard and stuff like that, and it access apps on the server. And it was based around Spartan 6, and they went out of business or something, and so you could buy the unit like super cheap, and a bunch of people bought them. I don't remember the name of that project, but as far as I know, as part of the gateway they developed for it in open source, was minimal USB host to talk to the keyboard. I don't remember the name of that thing. I know it had DVI on it. Oh yeah, it's thin client. Panalogic G2. That's the thing. And as far as I know, it has USB connected directly to the FPGA, and somebody wrote some code to allow to talk to a keyboard. So that could be a place to start. I haven't dug into it, right? But that might be a community to ask. I don't know if they have an IC or they have a Gitter, so you can try asking there or something. Yeah. Okay, so it should have finished. Yes, it did finish. Okay, so now we have what we want. We send the in packet. The device responds with its device descriptor. We knack, and we ask again, and the device sends us the same data again, which is exactly what we wanted. So assuming the test passed. Yeah, perfect. Good. So that's nice, because first, that's how to modify it and the device responds correctly. Cool. Okay, so what would be a proper way? Because at the moment I kind of just patch the thing sort of not very cleanly inside host receive, but obviously we need to find a way to pass the fact that we want to generate a retry manually. But we have like a ton of layer of indirection, like, because host receive is called by. If I need to add a parameter, that's gonna be a pain. So they do use self retry to pass stuff between functions. So I guess I could add. I could add, yeah, basically this like for snack or something. Do they do they have like a IC channel or something to this? Because like usually when I need to introduce, like that's not my project, right? It's Ant Micro's test suite. And when there is like a sort of an architectural decision of, you know, oh, okay, oh, are we gonna pass these kind of parameters between 7 layers of indirection? Like, what would be the best way, the cleanest way, and stuff like that? I usually like to talk with the guy that are responsible for the project before I kind of write anything, because they might not like my way of doing it, and they might have a better suggestion or something, and so I'm not gonna lose my time cleaning up something in a way that's not gonna get merged, right? Um, so if they have a gitter or something, I might try just asking them basically. If not, I'll just open an issue and ask them if that's an appropriate way to do things, stuff like that. Um, they have read documentation. I'm not sure if they have like a gitter or something. Are they on the? Maybe they're actually on the 1 bit squared GitHub, but I don't know the name of the guys. Or I mean I don't know their like their handle. Maybe I can figure that out from the commit names. Yeah, that's not gonna help me. Dependable. Yeah. Okay. Mm. Yeah, I need to search exactly who does that. Oh wait, are we? Oh wow, we've been going on for like 1 hour and 30 minutes. Damn, I didn't think it had been that long. Um, okay, maybe you just make. What are the names of the other? Oh, okay, I'm gonna save that. I'm not sure of the name of the other target, but let's try to run the test on Valenti USB, for instance. And see if it passes as well. Maybe we should have checked if the test passes before before I modified it. If the test doesn't pass, we'll just re-execute it without the modification. Speaking of the formula, I need to find, I need to buy, I guess, like a production version of the formula. Like I have tons of the Hacker board, like the one made by Mithra, which he distributed around, and I got a bunch of them to give away to people. But I don't have any production one, and I learned. I thought at first I thought there was no difference except like design for manufacturing and reliability and stuff like that. But actually, on the Hacker board, on the Hacker version, the flash is not wired for quad SPI operation. Only 2 of the data lines are connected, so you don't have the. Okay, it failed the test. Let's look at why and see if it passes it with the. Yeah, so in the Formula Hacker version, you don't have the 4 data lines connected, which reduces the max speed at which you can talk to the flash. Because like all the, like in my last stream, I talked about I/O timing and stuff like that, and the SPI one is because I was actually working on a SPI core for the BitC, which is going to run in quad SPI mode at 96 megahertz, which should provide me with like 48 megabytes per second of bandwidth. And that's the same reason I also developed the memory cache, which I presented on previous stream as well. That's to run on this board so that I can execute code from the flash with a cache that works well. And same thing for the PS RAM, for the pseudo-static RAM. And that's all part of the SoC that I want to get to run on this board. And ideally, I'd like to get it running on the Formu as well. But it might only support the production version of the Formu because I can't depend on quad SPI operation. And so all of that to say that I need to buy a production version of the Formu. Okay, so did it? No, it's still processing. So it failed the test. Can we see? So it basically always gets snack. Okay. Once it loaded, I'm just gonna re-execute the test without my changes to make sure that it did pass the test before, because maybe the current test setup is broken for Valenti USB. So. Damn. I mean, come on, it's not a slow machine. Like I would have expected the... Maybe I need to optimize the protocol decoder for Sigrocli because it takes a long time, right? Okay, so what happens? Okay, so yeah, it sends the data once, and here it's snacked. So that's me simulating an error on the bus, and then I re-ask the same data again, and the core should be sending me the same packet, but it's not. which means there's a bug in the Valenti USB thing. It should be sending this again basically, and it doesn't. So I'm pretty sure like if I didn't send a NAC here, it would have worked. So yeah, I'm pretty sure that the if I restore the test to the without simulating the error, that's not gonna work either. Okay, let's try another one. I'm not sure what target it supports actually. How can I list the targets? Let's test the tiny FPGA bootloader. We can actually try to have a look at the code and see if it has actually code to handle that case, like tiny FPGA bootloader. Common. So that would be USB full speed. Control endpoint. I've never looked at that code, which means I have no idea what I'm looking for. Yes, I could, but it doesn't. It wouldn't help because when you call the transaction filter process, GTK Wave does not send to SIGROC the entire VCD. It dynamically generates a VCD with just the USB signals, with just the two signals that are selected. So because you can feed the LXT file and stuff like that, and it will still give a VCD to SIGROC. So that wouldn't help. I think SIGROC is taking a long time because the VCD that I'm sending has update events basically for every time tick of Verilog, if you will, which means that it doesn't have updates only when the signal changes, but it has one every 1 nanosecond or something. And I think that's why it's taking a lot of time. There might be a way to change the time scale. Okay, so here it passes. It has warnings because it responds too slow. It takes more than 7.5 bit time, and it should take it takes 10.75, so it's a specification violation, but it still sends the data. Let's look at the trace. If I look at the VCD that's generated, yeah, see, it has a time scale of 1 picosecond. Although I don't think that actually changes anything because it does send only changes here. Yeah, so that might not change anything actually. I'd have to look at what I can do is modify the Python script. So if we look at the Python script, let's see. So I could modify this to oh well, you see, it actually saves it to a temporary file, right? So I should be able to find that temporary file and look at it. Okay, so that's the see that's the temporary file that has been given to Sigrok. And if we look at that file, see, it only has two signals. The USB USB DN and USB DP. It doesn't have all the others, and it's probably much smaller, right? Yeah, it's only 11 kilobytes, 12 kilobytes. So something in the processing of Sigrok makes it pretty slow to process those kind of files. I'm not sure what, but maybe that would be worth actually debugging in Sigrok, because see, it's like a 12 kilobyte file and it's still processing it, right? So I think at some point Sigrok must be expanding that VCE file yeah, that's what's happening. Okay, because Sigrok does not support, like internally Sigrok represents data as just a list of samples, or a linear list of samples, right? But completely expanded, which means it doesn't know it doesn't compress the samples, right? It's really just a flat representation in memory of what the signal is worth at every time step. And here the time step is freaking small. It's like 1 picosecond. And so it's like if you were feeding to Sigrok signal sampled at 1 picosecond would be 1 gigahertz, right? So okay, 1 giga samples. And so that's why Sigrok is slow. Something that would be worth doing, I guess, is instead of feeding it a 1 picosecond time scale, is to be able to even just divide all the timestamp per 10, for instance, and have a time scale of 10 picosecond. Let's see if we can actually hack something quickly. So here we could let me first check. Okay, it did pass it. I'm just gonna try to quickly hack the script to like divide every timestamp by 100. But first I want to see how this worked. And see here it worked correctly. So it did receive the in, I sent the data here, simulated an error, asked the data again, and I received them. That's 1 terahertz. Yeah, so yeah, okay. So that probably makes sense that SIGROC is has a hard time processing that, right? It's like feeding it like 1 tera samples per second to analyze. Yeah. So let's try to diminish that and make it to be only yeah, USB 5. To make it only 10 gigasamples per second, which is much more reasonable. So the first thing we need to find is the timescale command. Okay, I know that's absolutely ugly, but that might work, right? Basically, when I see the 1 picosecond resolution, I replace the line completely with one with 100 picosecond resolution. And then every time I see a timestamp tag, I take the timestamp tag and divide it by 100. Yeah, it's still 10 gigahertz, but the thing is, I mean, I guess I could divide by 1000, right? Max time. You know what? I have no idea what max time is for. But yeah, maybe I need to do that too. Is max time even needed? I'm not sure if SIGROC needs that max time. Let's just skip it for now. I'm not sure if SIGROC needs it, so we'll see if it still accepts that or not. So let's make that 1 nanosecond then, and then we divide by 1000. Okay. Okay, well that was faster, but I didn't process anything, so not great. So maybe it needs max time? No, max time is not the issue. No, instead of a temporary file, I'm just gonna save it in a file that's kept around so that I don't have to, so I can inspect the result of my modifications. With open did I screw up something? Yeah. Okay. Well, I crashed. The problem is when you process crashes, it pretty much crashes GTK wave. Which we know GTK wave is dead. So yeah, I need to. Oh, okay. Right argument must be string, not byte. Oh, damn it. What? Of course. Yeah, exactly. Yes, I just saw it. Yeah. So let's redo this now. Append. Combine up or down. Data format, transaction filter process, enable and select. Here. So it did something, but it didn't decode anything really. Let's look at the resulting file. What now? 0? What? Do we have a delete at the end or something? Yeah, okay, yeah. I'm deleting the data after. Oh, that looks correct to me. So maybe... Oh yeah, you know what's happening? Is that all the timestamps that are generated by the script are now... yeah, I need to modify the timestamps that are generated by the script, basically, to multiply them by 1000. Right? Because every annotation that I generate is time correlated, and I'm sending it to GTK wave in nanoseconds, and it's expecting them in picosecond. So I need to somehow do this. Now look at that. I have annotation that works and that are generated like 1,000 times faster. Okay, so yeah, I guess that's an improvement that would be useful for the script, is like a limit to the time resolution, to make sure we're not processing data at 1 terahertz. I'll need to modify the script to, I mean, I just did a quick hack. I need to properly interpret the time scale line and modify appropriately. Yeah, exactly. VCD decimation and interpolation. But that's nice. So now we tested tiny USB, and that passes the test. So let's go back to USB rather than SIGROV decoding. Can we run... What other target do we have? So we tested tiny FPGA bootloader, that passes. We tested mine, that passes. Valenti USB doesn't work. We can test USB 1 device, which is the Ant microcore. Yeah, definitely. I should definitely have looked into it way before, like, because it was definitely not normal. It was taking that long to process that capture, and I should have looked at it before instead of waiting unnecessarily. Well, I'm not sure, but I know that once you mentioned it, I remember that I had the same issue the last time I run this thing. I had completely forgotten, but I remembered. That's why I knew to look at the timescales, because I remember I had that problem and I had fixed it, like hacked it previously already. And I looked at changing the timescale, and as far as I remember, it's really not easy. Um, to change the default. I think it's just Ivory log just generates them to 1 picosecond resolution by default. Also because the oscillator is 48 megahertz, and so to keep its internal timing aligned to the proper timing and be able to generate timing errors and stuff like that. Because like one of the tests is testing if the USB core works if the USB clock from the host and the USB clock from the device are different by 1,000 ppm or something, which the specs says okay it should work. But that means that the values of the resolution it needs to simulate that kind of small timing errors is relatively high. It needs a high resolution internally. It's just that when we display it, we don't really care about it, but during the simulation, it might need that resolution. Okay, so it fails for a weird reason. Okay, let's just look at the result, which hopefully should now be near instant. So what's happening here? Okay, we need to re-add. We have the request, we have the first response that we knack, and then we ask again, but we never let it answer. Oh no, that's an empty packet. It sends an end of packet. Yeah, it sends an end of packet, so the simulation ended as an error, because that's not even a valid packet. Like the CRC is invalid, so that's just, yeah. Okay, so that doesn't work either. So that core is not working properly either in that case. See, that's why I wanted because testing a USB core when everything works fine is something like everybody does, because they test it on hardware, they plug it, and it works, right? But the problem is, like I'm running, I've used the USB core I worked on for like long-term stuff where it's plugged in the PC and it runs for days, exchanging data for days, like continuously, and I need the core to be reliable over a long period. And so it needs to be able to handle the retry procedure, because they actually happen. Sometimes it might be rare, but and everybody tests the core works when everything is fine and there is no transmission errors, but testing that it responds to error properly and according to the specs, that's obviously not as tested, it seems. So we have for boot, I think we can test too. So Tanya, if we did. So we can test for boot. We need to do make clean. Okay, we need another compiler. Yeah. How can I do? Is that the +5 non-embed? Oh, sorry. For me, the simulation still takes a bit of time to run. Well, it's not too bad. I wish there was faster simulator. Actually, like White Quark just updated her CX6RTL thing. I haven't tested that yet. Has anybody tested that? I don't know if in the chat here. It's like in the same style of Verilator, where you take Verilog and you compile it to C++, and then you actually compile that C++ and run it as kind of native code for simulation. Let me. Well, actually, yeah, I can just. It's one of her latest status, I think. Okay, this thing uses CX6RTL backend. Yeah, and she updated it today. I haven't tried it yet, but that looked interesting for simulation. It's basically it uses the Yosys parser and everything, and instead of writing of synthesizing to like a FPGA target, it basically writes the parsed Verilog and everything as C++ classes with a minimal runtime, and then you can write like a C++ test bench that generates the clock edges and the stimulus for your test bench, and yeah, writes the output as you want basically. Okay, that's a bit annoying yet, I guess. One issue is that for a lot of the stuff I simulate, I need to be able to simulate the vendor primitives, like the hardware blocks that exist in the FPGA somehow. And I have Verilog simulation models for them, but I need to be able to actually use them. Okay, so this the USB test bench is still running. I mean, as Mike pointed out, that's obviously an old version of Foboot from 6 months ago, so I don't know if it's been updated or anything, but at least we can test. Come on. I think once we check that out, I think I'm just gonna stop here because we've already been going on for like more than 2 hours, and I need to eat at some point too. Okay, so it failed. Let's see how it failed. It's a much longer trace. It takes longer to process, but I mean, yeah, there's an entire soft core and everything, so obviously it's a little more complicated. Okay. Oh wow, a lot has happened. Let's see. So we have our startup frame. We have our get descriptor request. Then we ask for data, and it answers that it's not ready yet. Perfectly okay. We send another in token. It responds with the descriptor data as expected. We send a NAC saying that we did not receive that packet correctly and that it should resend it. We send a new in request and it doesn't answer anything, and so yeah, it fails. So it doesn't work either, basically. And it doesn't do anything. It doesn't NAC. It doesn't. Yeah. So yeah, not. So yeah, among the 1, 2, 3, 4 among the 5 USB implementation, we have 2 that works basically for this particular test case. TNT USB and the tiny FPGA bootloader handle the retry correctly. The other will need updates. But that's only one of the failure scenario. I want to add test case for the other, because instead of not sending a NAC, you can also not send anything for some time, and then you can. Well, that's actually pretty much the 2 only scenarios for that failure, I guess. Then we can test the output, the failure here, where instead of sending data 0, we can send data 1. But there's plenty of other like failure scenario which are reflected in the specification here in those graphs. Make sure basically we test every branch of those graphs. I mean, here we only really have one, which is not ACK and timeout. But def do bc int o is slightly more complicated, I think. Yeah, that graph has definitely a lot more things that can go wrong, right? And so I want to make sure that we have test case for every possibility and that they test correctly and that they pass correctly, basically.